Hello Math 80 students. This video we're going to be talking about divisibility rules. It's not one of our sections in the book, however it is going to be useful for us as we look through section 1.7, which is factoring and prime factorization. It's helpful for us to know when certain numbers are easily divided into other numbers. What we're going to be doing in section 1.7 is factoring, which means to divide into other numbers evenly. You could think of factoring 10 into 2 times 5. In order to be able to factor well, it's important for us to know quickly when certain numbers are easily divisible. And so we have divisibility rules to help us differentiate when certain things will go in, and we can also tell then when they will not go in. So there are rules for the numbers 2, 3, 5, 6, and 10 to tell easily and quickly if a number is divisible by those values. We'll go through 10 first because to me it's the easiest and most obvious. In order to tell what the divisibility rule is for a certain number, we start by looking at that number's multiples. So it'll look like this for 10. 10, 20, 30, 40. This is going to continue on past 100, past 200, past 1,000 and 10,000 and 100,000. But another few examples more would be 150, 60, 170, and so on as well. The rule for number 10 is a visual rule, which means we can look at a number and tell instantly if that number is divisible by 10. And you might see it here. All of these numbers have something in common, which is that they all end in a 0. 10, 20, 30, and so on. And as I said, this will continue into the 10,000s, the millions, billions, trillions. Anytime it ends in a 0, we can tell instantly that it divides into 10 evenly. So for example, 160 is 10 times the number without the 0. So it's 10 times 16. Same with 180 is 10 times 18. So this is a way of dividing things quickly into much smaller and easier numbers to deal with. So the rule for 10 says that if it ends in 0, 10 will always be a factor. Now, not all of our divisibility rules are visual, meaning we can look and tell, but they are shortcuts to having to do long division for larger numbers. I'm going to start now with 2, which also is visual. Again, we start to tell what the rule is by writing out the multiples of 2. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. That'll go on. Again, this pattern repeats. Just like the 10s, I don't have to show you every multiple of 10 through a million because we know that this is a pattern that's going to continue. The same with the 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Some people might sum this rule up by saying if it's an even number, then a 2 will definitely go into that number or be a factor of that number. But what does it mean to be an even number? Well, the definition is that it's a multiple of 2, so that's a little bit circular. What we can say, though, is again using visual clues that these same numbers are showing up at the end of every value that we have listed so far. And those values are listed here. If the number ends in a 2, a 4, a 6, 8, or a 0, then a 2 is a factor of that number. So if we could come up with a huge number, 10,875,214, that's a huge number, and I don't know what that factors down to when I divide by 2, but I know that I can divide by 2 because the last number is a 4 and 2 goes into 4. So if the last number is a 0, a 2, a 4, a 6, or an 8, that's our divisibility rule, that a 2 is definitely a factor of that number. Okay? 3s are trickier. They aren't quite as intuitive, and they definitely aren't visual. You can't look at a number and pick something out that says definitely, yes, 3 is a factor of this number. Again, same as the other two, we will start with the multiples of 3. Now this one's not visual because there's no pattern to what these numbers end in. We have a 3, 6, 9. This one ends in 2, 5, 8. This one ends in 1, and then this a 2 and a 7, and a 0. And then we're kind of looping back around again. So we can't look and say the last number's this, therefore there's a 3 in it. But the trick isn't much more complicated. There might be a little bit of work involved, but not a lot. The divisibility rule for 3 states that if the sum of the digits is divisible by 3, then the overall number is divisible by 3. So let's talk about what that means. If I take the number 27, you might know right away that 27 is 3 times 9. That's correct. But for students who aren't familiar with that right off the bat, we need to have a way of knowing that yes, there's a 3 in there so that we can then do the division and find that 9 is the other factor. So 2 plus 7. Is the sum of the digits of this number. 2 plus 7 is 9. And we definitely know that there is a 3 in 9. Because 3 is a factor of 9, we know 3 is a factor of 27. I'll do another example of a much larger number. If we do the number 123, that's not on any multiplication table that we have ever seen before. So can we tell whether there's a 3 as a factor in this number? And we can. Again, we're going to take each number in the, each digit in the number and add them up. So we have 1 plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. 3 is a factor of 6. Right away, that lets us know there is a 3 factor of 123. And that will work for any number, no matter how many digits long. As long as the digits add up to something that has 3 in it, something that divides 3 evenly, then the original larger number will also have a factor of 3 involved. That's about as complex as our divisibility rules get. It's tricky, but go ahead and practice a couple, pick some numbers, and then see if it divides evenly. Hopefully your rule will match up with your result when you try to do the division. Okay, so we've done 10 and 2 and 3. Our next one is 5. 5 is once again a visual divisibility rule. The multiples of 5, 10, 15, 20, 25, 30, and so on. You might be able to pick out the pattern immediately. We have a 5, a 0, a 5, a 0, a 5, a 0, a 5, a 0. That's going to continue on forever. So our divisibility rule says if a number ends in 0 or 5, then 5 is a factor of that number. Again, we can use a really large number as an example and tell right away. If it's 675,245, I don't know what pairs up with 5 to multiply to this number, but I do know that it won't be a waste of my time to try to divide this number by 5. There's definitely a factor of 5 in that number because it ends in 5. So for 5, if it ends in 5 or 0, then 5 is a factor of that number. One more to go. And our last divisibility rule is for the number 6. 6 is a little bit different as well. It's not visual, but it's not all that difficult. The reason 6 is not that difficult is because it builds on 2 of the rules we've already talked about. So some of the multiples of 6 are and that continues as well. So we don't have anything visual for 6. This number won't ever end in a 1 or a 3 or a 5. And that kind of plays a part in our rules that we're using before. So the rule for 6 is if a number is divisible by both 2 and 3, then that number is also divisible by 6. So if we're talking about 54 and we're not sure if there's a 6 in it, we can do this. 54, let's see, it ends in 4, so we know there is a 2. And 5 plus 4 is 9, and there's a 3 in 9, therefore there's a 3 in 54, so there is a factor of 3. So we know there's a factor of 6 in the number 54. Okay, so I'm going to write on this board all of our divisibility rules. Hopefully you'll have them down in your notebook because they will help you in section 1.7 for determining what some factors are when we're breaking numbers down. So bear with me while I write those back out and get them down in your notebook as well. go ahead and have those in your notebook so that you are able to do some of the factoring in 1.7 a little bit more quickly. And we will see you in the next video.